ay1 minus by2 square. Okay. Now we are going to proceed to calculate the modulus of this bz1 plus az2. Therefore, mod bz1 plus az2 is equal to square root of the real part of this, which is bx1 plus ax2 square, and the imaginary part by1 plus ay2 square. Now if you square both sides, you are going to get bz1 plus az2 square is equal to bx1 plus ax2 plus by1 plus ay2 square. So now on the left hand side, what do you see? You see this mod of this square plus mod of this square. So we start from the left hand side. Left hand side is equal to az1 minus bz2 mod whole square plus you have bz1 plus az2 square. So you put the values we have calculated above. What are the values we have calculated above for az1 minus bz2 mod whole square? We have calculated this to be ax1 minus bx2 whole square plus ay1 minus by2 whole square plus, and for bz1 plus az2 we have calculated this to be this one bx1 plus ax2, this is a square here, plus by1 plus ay2 square. Okay, now you expand by your a plus b whole square formula. So you have a square x1 square plus b square x2 square minus 2ab x1 x2 for the first one. For the second one, you have a square y1 square plus b square y2 square minus twice ab y1 y2. For the third one, you have b square x1 square plus a square x2 square plus twice ab x1 x2. For the fourth one, you have b square y1 square plus a square y2 square plus twice ab y1 y2. Now you see this cancels with this and this cancels with this. Okay, so what are you left with? You are left with all this. Now you see a square x1 square is here, okay, and a square y1 square is here. Let's take them together. A square x1 square plus a square y1 square. B square x2 square is here and b square y2 square is here. So let's take them together. B square x2 square plus b square y2 square. Okay, so what else is left? B square x1 square is here and b square y1 square is here. Let's take them together. B square x1 square plus b square y1 square plus now you have a square x2 square and you have a square y2 square. Right? So now from the first two, you can take a square common to get a x1 square plus y1 square. From the next, you can take b square common to get x2 square plus y2 square. From the next two, you can take b square common to get x1 square plus y1 square. And from the last two, you can take a square common to get x2 square plus y2 square. Now, what is x1 square plus y1 square? If you see here, x1 square plus y1 square was mod z1 square. So put the value here, a square mod z1 square. Similarly, b square was mod z2 square. plus b square, this is mod z1 square, plus a square mod z2 square. Now you see, take the first and the last one together. So a square z1 square plus b square z plus a square uh, z2 square mod z2 square plus b square mod z1 square plus b square mod z2 square. Now from the first two you can take a square common to get mod z1 square plus mod z2 square, and from the third and the fourth terms you can take b square common to get mod z1 square plus mod z2 square. Now from these two you can take mod z1 square plus z2 square common to get a square plus b square into mod z1 square plus mod z2 square, which is equal to your right hand side. Okay, any question? That is what you had to prove. See, this was your right hand side. No question?
No, sir.
Fine. We move on to the next problem then. Number 6. Given x plus yi is equal to a plus bi divided by c plus di. You need to prove that x square plus y square is equal to a square plus b square by c square plus d square. Okay, this is a very simple problem. You take mod on both sides. Okay. Now the mod of x plus yi will be positive square root of x square plus y square. And here you can distribute the mod between the numerator and the denominator from the properties of modulus. Can give you a reason here also, since that is the property. Now mod of a plus bi is the positive square root of a square plus b square, and mod c plus di is the positive square root of c square plus d square. Now you square both sides to get the required proof. Which is the required proof? Okay. So this was a simple enough problem. Let's look at the next one. Okay, number 7. Given here is x plus yi is equal to um, square root of a plus bi divided by c plus di. Okay. First of all, what you do is you square both sides to remove the radical. Okay. So you get x plus yi whole square is equal to a plus bi divided by c plus di. Now once we have removed the radical, now we take modulus on both sides. Mod x plus yi whole square must be equal to mod of a plus bi divided by c plus di. Okay, now this is a very important step. We are going to use the property of modulus, that mod, the square of the mod is equal to mod of the square of a complex number, the modulus of the square of a complex number is equal to the square of the modulus. That means you can write this as x plus yi whole square is equal to, and you can distribute mod between these two. Since mod, if you recall this property, mod of z square is equal to mod of z square. This is the property that I'm using here. So now, what is mod x plus yi? Mod x plus yi is root over of x square plus y square. And because you have a square, you put a square back. And here you have mod a plus bi is equal to a square plus b square. And denominator you have c square plus d square. Okay. So that means you are getting x square plus y square is equal to square root of a square plus b square by c square plus d square. Now you square both sides again to get x square plus y square whole square is equal to a square plus b square by c square plus d square, which is what we wanted to prove. Okay, no question.
No, sir.
We can move on to the next one then. Number 8. Given here is 1 plus I, 1 plus 2i, 1 plus 3i, and so on up till 1 plus ni, where n is a natural number, is equal to x plus yi. You need to show that 2 into 5 into 10 into 1 up till 1 plus n square is equal to x square plus y square. This is very easy. You take mod on both sides. If this is equal to this, then mod of 1 plus I into 1 plus 2i into 1 plus 3i, and so on up till 1 plus ni is equal to mod x plus yi. Now you can take individual mods. That means mod 1 plus I into mod 1 plus 2i into mod 1 plus 3i, and so on till mod 1 plus ni is equal to mod x plus yi. Why? Because you know that modulus of the product is equal to product of the moduli, right? This is the property that we have used. Now mod 1 plus I can be written as 1 square plus 1 square. Mod 1 plus 2i from definition is 1 square plus 2 square, 1 plus 3, 1 square plus 3 square, and this is 1 plus n square is equal to x square root over of x square plus y square. Okay, so you are getting here root 2 into root 5 into root 10 and so on. The root 1 plus n square is equal to square root x square plus y square. So squaring both sides, we get root 2, root will be removed. If I square both sides, there will be no radical. You get 2 into 5 into 10 up till 1 plus n square is equal to x square plus y square. And that is what we needed to prove. Okay, as simple as this. Moving on to the next one. This is number 9. Given here is 1 plus I by 1 plus 2 square I into 1 plus 3 square I by 1 plus 4 square I into and so on. This continues till 1 plus 2n minus 1 whole square I divided by 1 plus 2n whole square I. This is given to you equal to a plus bi by c plus di. You need to prove 2 by 17 into 82 by 257 and so on is equal to a square plus b square by c square plus d square. Now once you see on the right hand side a square plus b square by, and denominator you see c square plus d square, you know that a square plus b square is nothing but the modulus of a plus bi, and c square plus d square is nothing but the modulus of c plus di. So that means obviously you'll have to take mod on both sides. Let's take mod on both sides. Okay. Now we can take individual mods. Product of the moduli. And you can distribute this modulus over the numerator and the denominator. Right. Now in the next step, you can also distribute the modulus over the numerator and the denominator. And this will continue. And here modulus a plus bi is root over of a square plus b square. And this is root c square plus d square. Now here the modulus is, in the numerator it is root over of 1 square plus 1 square. And here the modulus is root over of 1 plus 2 square square, right? And here this is root over of 1 plus 3 square square, root over of 1 plus 4 square square. And this continues to get root over of 1 square plus 2n minus 1 square. Let me put this into box brackets. Square 2n minus 1 square square divided by root over of 1 square plus 2n square square is equal to square root of a square plus b square divided by square root of c square plus d square. Squaring both sides, radical will get removed from both the sides, so that 1 square plus 1 square will give you 2 divided by, and denominator, if you 2 square square is 2 to the power of 4, 16 plus 1 will give you 17, right? Into this one. What about the next one? There is no square root because we have already squared. 3 square square, 3 to the power of 4, 3 to the power of 4 plus 1 will give you 81 plus 1, which is 82 divided by, and here similarly you will get 257. 256 plus 1, 4 to the power of 4 is 256, and so on till you get 2n minus 1. 2n minus 1 square square will get 2n minus 1 to the power of 4 plus 1 divided by 2n to the power of 4 plus 1 is equal to a square plus b square c square plus d square. And that is what you have to prove. Clear? Can I move on to the next one?
Yes, sir.
Now, in fact, the next problem is actually out of your syllabus. So, no point doing number 10. You can cancel out number 10 from here. Okay, this year it has been removed from the syllabus. Okay, I'll move on to number 11 because um, this sum requires you to use triangle inequality, and triangle inequality is no longer there in the syllabus. No longer there in the syllabus means only for you for this year, or maybe for next year, or for the next 3-4 years. It is very surprising that we talk about years nowadays as if it was days, isn't it? 3-4 years, as if it's 3-4 days. Pandemic will
Yes,
continue.
sir.
Pandemic will continue for 3 years. You see what 3 years means? As if we are taking 3 years. 3 years. I mean, what will happen in 3 years? Pandemic will end in 3 years. 3 years. Where will I be? Where will you be in 3 years? As if you're talking about 3 days. Okay, number 11. Number 11, the problem here is find the complex number satisfying the equation uh, mod z minus 12 by mod 8 minus 8i. And you have another one. Two relations are given here. So given okay, you need to find the complex number z. So I say let z is equal to x plus iy, where x and y both are real. You don't need to write x and y are real. X plus y means x and y have to be real. Anyway, so therefore now look at the first relation. You've got mod z minus 12 divided by z minus 8i is equal to 5 by 3. Put x plus yi in place of z. X plus iy minus 12 divided by x plus iy minus 8i is equal to 5 by 3. Now you can take modulus in the numerator and the denominator, and the numerator also you will separate the real and imaginary parts to get x minus 12 plus iy divided by mod x um, plus y minus 8i is equal to 5 by 3. So now the modulus of this will be how much? X minus 12 square plus y square, x square plus y minus 8 square is equal to 5 by 3. Square both sides to remove the radical. X minus 12 square plus y square divided by x square plus y minus 8 square is equal to 5 square by 3 square if you square both sides. So that means we get x minus 12 whole square plus y square divided by x square plus y minus 8 whole square is equal to 25 by 9. Now you cross multiply to get 9 times x minus 12 square plus y square is equal to 25 times x square plus y minus 8 square. Okay. Now you expand within the curly brackets, you expand x minus 12 whole square, you will get x square minus 24x plus 12 square, which is 144, plus y square is equal to 25 times x square plus y minus 8 whole square is y square minus 16y plus 64. Now you multiply by 9 throughout, you get 9x square minus 216x plus 144 into 9 is 1296 plus 9y square is equal to, now you're on the right hand side, you multiply by 25 throughout, 25x square plus 25y square minus 25 into 16 is 400 y, and 25 into 64 is 1600, right? Now you take the x squares together, that is you take 9x square on from the left hand side, you take it on the right hand side. So you'll get 25x square minus 9x square equal to 16x square. And this y square, this 9y square, if you take on the other side, you will get 16y square. Okay, and this similarly you do for the others, you get 216x minus 400y plus 304 is equal to 0. Now obviously from here you can take 4 out to get 4x square. 4 is a common factor, plus 4y square plus 54x minus 100y plus 76 is equal to 0. So that means you are getting 4x square plus 4y square plus 54x minus 100y plus 76 is equal to 0. From the first relation, we are getting the first equation, this one. Okay, now we start with the second relation. Second relation is mod z minus 4 by z minus 8 is equal to 1. Also, mod z minus 4 divided by z minus 8 is equal to 1. Put the value of z, x plus iy minus 4 divided by x plus iy minus 8 is equal to 1. Now distribute this over the numerator and the denominator. Separate the real and imaginary parts. Iy is equal to 1. Now you take the modulus here. You get root over of x minus 4 whole square plus y square divided by root x minus 8 whole square plus y square is equal to 1. Squaring both sides. We get x minus 4 whole square plus y square divided by x minus 8 whole square plus y square is equal to 1. Now you cross multiply. X minus 4 whole square plus y square is equal to x minus 8 whole square plus y square. Now you expand. X square minus 8x plus 16. In fact, this y square will cancel. So no point writing y square. So you get is equal to x square minus 16x plus 64. So now again this x square will go. So you'll get 8x is equal to 48. So you'll get x is equal to 6. We have got the value of x. How to get the value of y? From 1, putting x is equal to 6. We get, if you put x is equal to 6, what do you get in the relation 1? What was the relation 1 here? This one, right? Put x is equal to 6 here. You get 4 into 6 square plus 4y square plus 54 into 6 minus 100y plus 76 is equal to 0. So here you're going to get a quadratic. Means you get y square minus 25y plus 136 is equal to 0. You can factorize this quadratic into y minus 17 into y minus 8 is equal to 0. That means either y is equal to 17 or y is equal to 8. So therefore, x is, what are the values? X is equal to 6 and y is equal to 17. So that what is the value? What is the complex number we are getting? Z is equal to 6 plus 79 or x is equal to 6 and y is equal to 8. So that z is equal to 6 plus 8. Okay, I'll stop here.